Good afternoon, everybody. We are going to take a look at the dump truck problem that I would imagine is giving a lot of people issues at this point from physics. A dump truck whose bed is made of steel holds an old steel watering trough. The bed of the truck slowly raised until the trough begins to slide. For dry steel on steel, mu sub s is 0.8, mu sub k is 0.6. You can see I've already got my force diagram drawn. I drew a triangle. Obviously, it's a bed of a truck, but a ramp is a ramp, so it really doesn't matter. But we've got our force of gravity downward. We've got our normal force perpendicular to the surface, and we've got our force of friction moving up. This is going to work out to be a two-part problem because we need information in order to figure out what the acceleration is. We need some information that's not given to us. Mainly because we don't have, whoops, we're going to undo that. Sorry, I didn't realize I was on mute here. We don't have our angle. We don't know at what point it starts to slide. To know what our forces are going to be, we need to figure that out first. So I've got my force diagram. We're going to break down our angled forces into their perpendicular components. And what we have to realize is that moment when it just starts to slide, our gravitational force in the x direction is going to be exactly equal to our force of friction static max. Right? That's that point, that's that breaking point, right when it begins to slide. Well, we need to figure out when that's going to happen. Okay? So if we think about some of the other things we know, in order to know what our force of friction static max is, we know that our force of friction is equal to mu times my normal force. Again, we don't have that either. We know that our gravity force, right, always equal to mg. Our x, if we go back and let's do this in red, our force of friction in the x direction is going to be equal to, I said force of friction. I'm sorry about that. We want our force of gravity in the x direction is equal to Fg times the sine of theta. Our force of gravity in the y direction is equal to gravity times the cosine of theta, right? And now we can start filling in some of our missing stuff here, right? We know that if we start looking at our force of gravity x, Fgx is equal to Fg times the cosine of theta. Fg, as we know, is equal to mg. So Fgx is equal to mg cosine of theta. Okay, still at this point, that doesn't get us to where we need to be. So let's go ahead and figure out what our normal force, or our force of friction is going to be, right? So we're going to switch into a different color here, and we're going to say our force of friction static max is equal to mu sub s times the normal force, which the normal force is actually just going to be equal to Fgy. So we can say the force of friction static max is equal to mu sub s times Fgy. Or if we plug in what we have for our Fgy, our force of friction static max is equal to mu times mg cosine of theta. And I'm going to take those two and I'm going to set them equal to each other. Force of friction static max being equal to our Fgx. And I'm going to take what I plugged in for those and substitute, or what I just figured out, and substitute those in. Force of friction static max is equal to mu mg cosine of theta is equal to our FGX, which is FG sine of theta. And I am very sorry. I just realized that I was plugging in cosine of theta all along here. So now that we've got those equal to each other, and let's go all the way with this substitution, right? Equal to mg sine of theta. And over here we've got mu mg cosine of theta. Well, if we start looking at things here, we've got our m, we've got g, we've got m, we've got g. I can then go ahead and I'm going to divide both sides by the cosine of theta. Divided by cosine of theta. And I am left with mu sub s is equal to sine of theta divided by cosine of theta. Well, for the math nerds out there, we know that sine divided by the cosine, sorry about that, means mu sub s is equal to tangent of theta. I already have mu sub s. What I'm actually looking for is my theta. So I'm going to take the inverse tangent of both sides. Inverse tangent of mu sub s is going to be equal to the inverse tangent of the tangent of theta, which means those go away, and I'm left with the inverse tangent of mu sub s is equal to theta. Once I have my angle, now this actually goes back and becomes very similar to a problem we had on the last Mastering Physics, where once the object started to move, we continued to push it with just enough force to make it keep, with that just enough force that made it start moving, which means we're going to keep FGX equal to my static friction force max. And now that I'm moving, my force of friction is equal to my kinetic friction. Okay, so keep in mind, we've already found solved for theta. I'm going to leave it as theta. I'm not going to start plugging in any numbers here. Just recognize that tangent to the -1 inverse tangent of mu sub s is what's going to give us our theta. That brings us then to part 2 of the problem. I'm going to bring my drawing back down here so that we can kind of see it a little bit better, so that it stays with us. We don't have to keep scrolling up and down as we're trying to do this problem. So there's that. And I'm going to go ahead and plug in, recreate my force diagram, right? So we've got force of gravity down, we've got that normal force is perpendicular, and we've got the force of friction going up the ramp. I'm going to fill it in as force of friction K, because with this being part 2, the object is moving, so it's the force of friction force of kinetic friction. Let's go ahead and break things down into those perpendicular components. Now, if you remember, we're leaving it right at that same angle that we found. So my FGX is actually equal to my force of friction static max. And I'm going to leave it that way because that's going to be important to us later. And then this is my FGY. Okay. So what I need to do is I need to know the acceleration. Well, this just turns into a second law problem, right? So I'm going to create my XY bar chart. On the Y side, we know my acceleration is 0. So my up forces equal my down forces, which means Fn is equal to Fgy. Just like in the last one. I am going to accelerate in the X direction, which means I'm going to deal with F net is equal to MA, and F net is equal to my big force minus my little force. We can pretty much assume that this is going to slide down the ramp. So F net is equal to Fgx minus force of friction. Right, so now what I need to do is I'm going to start plugging things in, right? I'm going to substitute in my net force equation, F net is going to be equal to, I'm going to take my force of friction static max and plug that in for Fgx. So my F net is going to be equal to force of friction static max minus my force of friction kinetic. Again, that is just substituting in force of friction static max is equal to Fg, because we left it at that moment where the angle where it had just started to slide, which means my pushing force, my driving force, my big force is still just exactly what it was to get it to keep moving, right? So my net force, I can go ahead and start plugging things in on this. My force of friction static max, sorry, we're gonna move that, is mu sub s times my normal force minus my force of friction, which is going to be mu sub s, or excuse me, mu sub k start over with that one. Sorry about that. Mu sub k times my normal force. Both of my normal force is still equal to Fgy. So I'm going to say mu sub s Fgy is just going to be mg times the cosine of theta minus mu sub k mg cosine of theta. All of that is going to be equal to F net, which is just equal to MA, which means we can go ahead and we're going to get rid of all of my M's. They didn't give us an M, so we're lucky that that happens. And our acceleration then is just equal to mu sub s times the cosine of theta minus mu sub k times the cosine of theta. Again, so we needed to work to get that first part of the problem done, to figure out what that theta is. Oops, sorry, forgot my G's. To get with that first, to do that first part to get the theta, and then once we have theta, we can turn around and we can plug it in to get this problem. Hopefully this helps you guys get through this problem. I would personally treat it like a variables only problem first, and then from there go ahead and plug in numbers, especially because they don't give you a lot of numbers, and it'll be good practice as far as variables only problem.